Now see the shapes of d orbitals. Now there are totally 5 d orbitals in any subshell. In the main shell, there are the d subshells, and in d subshell there are 5 d orbitals. Now see the different shapes of the d orbitals. Now this is the first d orbital. The name of this d orbital is dxy. Now the 5 d orbitals are dxy, dxz, dyz, dx square y square and dz square. All the 5 different d orbitals are shown here. Now see this dxy orbital. This is on x and y axis. Now this is the dxz orbital on the x and in between z axis. Now this is the dxz orbital. The shape of this dxz orbital is in this way. These are the complicated shapes. Now this is the dyz orbital. Now third orbital, dyz orbital. The fourth one is the dx square y square. Now these are on x and y axis. This d square y square orbit is on x and y axis. Their lobes. They are also here dumbbell shape. And this is the last d orbital, dz square on the z axis in this way, and this is the fifth d orbital, that is the dz square orbital. Now see how the electrons are filled actually into the different orbitals. Now there is the order of filling of these electrons in the orbitals, and that order is increasing order of energies of orbitals. That means the lowest energy orbital filled first by the electron, and this is given by this above principle. Now the meaning of above is, this is the Greek word, above is the Greek word, and it means that building up. But here we have to take the meaning is filling up the electrons in the orbitals. Filling up means above, that is the building up. Now filling up the electrons in the orbitals, and always remember that the lowest energy orbital fill first. Now I write here, now in this way the order of filling of the electrons in increasing manner. Now this first one, 1s orbital, it is the lowest energy orbital, 1s orbital. After that 2s, which have somewhat higher energy, then 2p, then 3s. In this way energy increases of these orbitals, and electrons get filled in these orbitals. Now how we remember the sequence? Now the sequence is remembered by this simple diagram. Now draw the circles in this way, as we know that in the first main energy level, when n is equal to 1, this is the first main energy level. Now in this first main energy level, only one orbital is there, and only one subshell, S, 1s subshell, it has only one orbital, this 1s orbital. Now this is n is equal to 2, second principal quantum number, n is equal to 2, second main shell, which contain two subshells, 2s and 2p. Now this is n is equal to 3, it contains 3 subcells, 3s, 3p and 3d. We know about that. Now this is the n is equal to 4, it contains 4 subcells, 4s, 4p, 4d and 4f, and in this way n is equal to 5. Now these are 5s, 5p, 5d and 5f. Now draw the circles for each orbital in the main shells and then go at the bottom of this diagonal. Now I draw here the diagonals in this way. Now come first to the bottom of the diagonal. Now this is first 1s orbital. So I write here 1s. After that again go to the bottom of the diagonal here. Now here comes 2s orbital. Now this is the 2s orbital. Again go to the bottom of this diagonal. Now this is the 2p orbital and this is the 3s orbital. So first 2p comes and then 3s. 2p, 3s orbital. Again go to the bottom of the diagonal. Here 3p orbital first and then 4s orbital. 3p and 4s. 3p have lower energy, 4s have higher energy. Again go to this diagonals, bottom of this diagonal. Now here is the 3d orbital, then 4p orbital and then 5s. Now see here 3d, 4p, after that there is the 5s orbital. And in this way we can remember the sequence of increasing energies of these orbitals. Now we know that in each orbital there are maximum 2 electrons are filled and their spins are opposite. We know that. Now how that filled? Now how is the sequence? How we remember that sequence? See here, we can remember the sequence in this way. Now the sequence is in this way. After that, now 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 5p6, 4p6 and 5s2. Now in the s orbital, now this s orbital, now it does not split again into that is the orbitals. Now suppose this is the any s orbital. S orbital contain, it may be 1s, 2s, 3s, 4s in this way. Only it accommodate only 2 electrons. They are shown by the arrow and the uphead arrow shows that the plus half value and the downhead arrow show the minus half value of the spin quantum number. Now this s orbital accommodate only 2 electrons. So I write here 1s2. Now in the 2s orbital there is also the 2 electrons, so 2s2. Now here 2p orbital have 6 electrons. How that? Because we know that the p orbital, any p orbital, there are the three types of p orbital. Now these p orbitals are, suppose this is the that is the 2p orbital. So it contains 2px, 2py, 2pz orbitals. 3 types of p orbitals are there. And in each orbital, it accommodates maximum 2 electrons. So this p orbital can accommodate totally 6 electrons. So I write here 2p6 in this way. Now p orbit contain maximum 6 electrons. Now I write here 3d10. Suppose this is the d orbital, any d orbital, but I write here suppose this is the 3d orbital and it have 5 different d orbitals, that is dxy, dyz, dxz, dx square y square and dz square. We already see the shapes of these d orbitals. Now there are the 5 types of d orbitals. Each orbital contain maximum 2 electron with opposite spins. They are anti-parallel. Their spins are anti-parallel. As there are 5 different d orbitals, so the total number of that is electrons in the d orbital accommodated by this d orbital are 10. So I write here 3d10. And again the p orbitals are there and f also there. After this 5s, this 4d comes, then this 5p, and then these 4f's. Now see this 4f. So f orbital contain 7 total different types of f orbitals are there also. Now f orbital, they have 14 electrons in them. In f orbital there are 14 electrons. Suppose this is s orbital, I write here 1s. Now see the f orbital. It contains 7 orbitals. 1, 2, 3, 4. This is 5, 6 and 7. 1, 2, 3, 4, 5, 6, 7. And suppose this is the any f orbital. Suppose it is 4f orbital. Now it accommodates maximum 14 electrons into that. Now if I increase this sequence up to 4f, then 4f contain 4, that means f orbital can contain 14 electrons. Now these are the 14 electrons. In the any f orbital we can write the 14 electrons. In this way, the above principle says that the electrons are filled in the lowest energy level first, in the lowest energy orbit, and then as the energy increases, the electrons fills in that orbitals. Now see this sequence. Now see, this is the second principle about the filling of the electrons. The name of this principle is the Pauli's exclusion principle. The name of the scientist is Pauli. Now, in this principle, he states that no two electrons in an atom can have the same set of 4 quantum numbers. That means, in any atom, the 2 electrons in the orbit do not have all the 4 quantum numbers values same. That means no 2 electrons in an atom can have the same set of all 4 quantum numbers. That means the quantum numbers, principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. All these 4 quantum numbers do not have the same value for any 2 electron in an atom. Now for example, see this helium. We know the helium is the inert gas, first inert gas having atomic number Z is equal to 4. That means there are 4 electrons. Now the electronic configuration of this helium is 1s2. The first 1s orbital is completely filled by these 2 electrons. And we know that in the orbital, the electrons are filled by this opposite spin. One is clockwise, another is anti-clockwise. Now all the 4 different quantum number values of these 2 electrons are given here. Now see the first electron. Now first electron in the principal quantum number, principal quantum number is 1. So n is equal to 1 here. As n is equal to 1, L is calculated as n minus 1. So 1 minus 1 is 0. So L is equal to 0. And M is calculated as from minus L 0 to plus L. We know that. Now as L is 0, M is also 0. And the spin quantum number have only 2 different values, plus half and minus half. As it is upward pointing arrow of this electron, so its value is plus half. Now here the set of 4 quantum numbers are in this way. 1, that is the principal quantum number, 0 azimuthal quantum number, 0 magnetic quantum number and plus half, that is the spin quantum number. Now all the 4 quantum number have this set of values. Now about this second electron. Second electron also, as it is in the 1s orbital, so this that is the principal quantum number is 1. Here azimuthal quantum number is a 0 here also, as 1 minus 1 is equal to 0, n minus l we can calculate in this way the value. And this is magnetic quantum number is also 0, and spin quantum number here, as it is the downward pointing arrow, so the spin quantum number is minus half. Now these are the values set of different 4 quantum numbers. The values are 1, 0, 0 and minus half. From these two 1s electrons, we can say that no any 2 electrons, because if there is the lithium, it have the quantum that is atomic number 3. Now into that 1s orbital is completely filled and 1 electron goes to the 2s orbital. There also again that is the principal quantum number changes and so on. So there are again different sets of values of 4 quantum number of different electrons into the higher orbitals also. This shows that no any 2 electrons in the atom can have all the 4 quantum number values are same. In another language, only 2 electrons can occupy in the same orbital, but they must have the opposite spin. Now this is the Pauli's exclusion principle. Now see the third, that is the rule here about the filling of the electrons into the different orbitals. Now see the rule is Hard's rule of maximum multiplicity. What is this rule says? This rule states that pairing of electrons in the orbital, such type of pairing of electrons in the orbital belonging to the same subshell, does not occur unless each orbital belonging to that subshell has got 1 electron. Now see how it is there. Now come by taking the example here. Now here I take the example of nitrogen. Nitrogen have atomic number 7. That means there are 7 electrons, and the electronic configuration of nitrogen is 1s2, 2s2. Now these are 4 and 2p3. 7 electrons